Now we are going to discuss what is DOL or Direct Online Starter. A simple type of starter method is DOL or what we call the Direct Online Starter or other calls across the line starter. The DOL starter consists of physically a three-phase induction motor and a switchboard panel which houses the components which are visibly seen at the outside of the panel. The switches, which are the green switch for starting, the red switch for stopping the motor. It also includes the emergency stop button and the three pilot lights for standby, the green for run, and the red for stop. And of course, the load meter. Inside the switchboard, it comprises a circuit breakers here and fuses. Other industry plant has no fuses, so these are optional. So let's just say that in our plant industry, there are fuses. But of course, we should rely on the circuit breakers. We have here the contactors and the overload relay for the protection of the motor. The unlocking of an electromagnetic contactors can be done through the thermal overload relay beneath fault conditions. If any error takes place, then holds on contactor gets deactivated. Therefore, the DOL starter separates the induction motor from the mains supply. In here, we find the DOL direct online starter electrical diagram. We have here the what we call the control circuit, and we have here the what we call the power circuit. And of course, we have here the what we call the control lights. What is an electrical diagram? Electrical diagrams are drawings which are used to represent electrical circuits. These circuits are represented by using lines and symbols. Electrical diagrams show the wirings between components and the relative position of the components. With the help of the electrical diagram, we could get a better understanding of the electrical circuits, which are usually used in industry. In order for us to do the electrical wiring in a plant, electrical diagrams are used as a reference. Now we proceed to simulate this direct online starter diagram. So from here, the circuit breaker is open. We are now going to close. We are going to switch on the circuit breaker. As we can see here, switching on the circuit breaker. So the circuit breaker is closed. We can see that the current now enters into the system. It cannot penetrate because we have here contact is open. But we have only activates pilot lamps standby because we have continuous flow of the current activates the standby light. Since our contact is normally closed, so the current passes through and activates the pilot lamp stop. We are now going to push the button to start the system. So in here, by pushing the start button run, we closes the contact. We let the current pass through to energize contactor coil C1. Since our contactor coil C1 energizes and we closes the main contact which is normally open. From normally closed, we open the contact here, and from normally open, we close the contact here. That is why it switches the pilot light from stop to run. Since we have now here the main contact closed, we let the current passes through and go to the load three-phase motor and it runs. Now, I take out my finger with the start button, but the holding contact is still closed because the contacts is being energized by the contactor coil. Now the system is running because we find it here in the indicator meter. We are now going to stop the system by pushing the stop button. So in here, the system is running, we are going to stop the system. We open the line here by pushing the stop button to interrupt the flow of the current into the system. By opening the stop button, the current is being interrupted and de-energizing the contactor coil. Since the contactor coil is de-energized, close contact at the holding contact is now open. The main contact, which are closed before, now is open because we deactivated or we de-energized the contactor coil. So main contact is open, we interrupted the flow of the current. And the pilot light here, we only interchange from run to stop. I take out my finger and the system is stopped. We have here now, what we see is we have the load meter stop. What about if the system is running? Then we are going to push the emergency stop. So let's try to simulate. So we have here the system is running. Then we are going to push the emergency stop button. By just simulating it here, the system is running. Then we are going to push the emergency stop button. And here, we interrupted the flow of the current into the system and the contactor coil is de-energized, then the current is interrupted. Since we push the emergency stop button, it holds into open position. And in here, we should have to reset the button. By just only handling the emergency stop button, then we reset the system and ready to use. Now we are going to simulate the DOL Direct Online Starter at the AKTS applications. We have here the control circuit, we have here the power circuit, and we have here the control lights. By simulation, switching on the circuit breaker, we can push the start button and we find it, the motor runs. So we find it in the diagram, we energize the contactor coil, it closes the main contacts and the holding contacts as well. Even I take out my finger, still holds because the coil is energized. The control lights, we find it here, just only changing with each other. By pushing the stop button, the motor stops. Start, stop, start, stop. How about the system is running and we push the emergency stop button? Okay, the system stops and we cannot start the system because the emergency stop button is still holding, opening the line for protection. So we have to do something, we have to rectify whatever the fault is. Then if everything is okay, then reset the emergency stop button and the system is ready to start again. So this is how DOL Direct Online works and it can be simulated at the AKTS.